Hello and welcome to the Lancet Neurology podcast. My name is Nikolai Humphreys. Today the topic is Alzheimer's disease and a review published in the April issue titled Neuroinflammation in Alzheimer's disease. I am joined on the line by one of the lead authors, Dr. Michael Haneke. Michael, welcome to the podcast.
Hi, Nikolai. Thank you for inviting me, and it will be a pleasure to answer your questions.
Could I ask you to briefly introduce yourself and to explain what role you had in this review?
Well, so I'm a neurologist, and I'm working at the Bonn University and at the newly founded German Center for Neurodegenerative Disease. And the basis of that review was a meeting we were holding in 2013, which was entitled the Third Venusberg Meeting on Neuroinflammation, and basically we thought at that time we need to summarize the new evidence for an important role of inflammatory mechanisms in this degenerative disease, and asked all the speakers to contribute. And basically it was my work then to put all these different contributions into one readable file.
Thanks, Michael. If we take a few steps back, we go right to the beginning, what exactly is neuroinflammation?
So neuroinflammation classically would have been viewed as the brain-resident micro and astroglial cell response to degeneration, cell damage, or infection, but is now a wider used term which also involves the infiltration and contribution from cells from the peripheral immune system.
Now, this is going to be a difficult question. You cover a huge amount of material in your review. Could you give us a little summary of what we know about the inflammatory reaction in Alzheimer's disease?
So what we believe is that very early when amyloid beta gets deposited, the microglia cell is equipped with pattern recognition receptors which sense the deposition of misfolded and aggregated amyloid beta. And this sensing is evolutionary developed most likely since millions of years. So you have to know that in our gut, some of the bacteria carry beta sheet structured amyloid on their surface by nature. So meaning that our immune system has been taught by evolution that this signal is a foreign aggressor and a pathogen. So when the microglia inside the brain now recognizes this misfolded structure, it may misread this as a pathogen and mounts a huge inflammatory reaction. And there is increasing evidence described in our review which shows that this inflammatory reaction is a potential driver of disease progression.
Okay, thank you. That makes a lot of sense. I've got a question now about the disease pathology. So amyloid beta and tau pathology might start to build up many years before people show symptoms of the disease. Now, does the immune system have a role in these very early pre-symptomatic stages of the disease, or does it come into play later on?
Absolutely. So I think that if we look now to data coming from clinical observations and biomarker observations, we will see that there is more and more data coming to light showing that in the MCI phase, or maybe even earlier, the immune reaction is stronger than in the late stages of, let's call it, end-stage Alzheimer's disease, the one which is clinically apparent and characterized by Alzheimer's dementia. And from a mechanistical point of view, you would conclude that inflammatory or immune mechanisms play a role even earlier. As soon as I said previously, as soon as the sensoring system on the microglial surface recognizes this misfolded and aggregated protein, within a very short period of time, these cells will respond by mounting an inflammatory answer. And that means as soon as the first amyloid beta deposition starts, you will get an immune reaction involvement.
In the review, you say that some of the genes that increase the risk of Alzheimer's disease encode factors involved in the inflammatory reaction. Now, does the immune system have a causal role in Alzheimer's disease, or does it come into play in response to the disease?
I would not say that we have, neither way we can't exclude a causal role, nor we can prove it. It certainly is at a certain time point in the driver's seat of disease progression. There's a recent paper by Marco Colonna, for example, published in Cell last Friday, showing that TREM2, which has a role as a risk factor for sporadic AD, has a phenotype showing that microglial cells, when they try to get rid of the amyloid beta deposit, undergo cell death instead of staying there and doing their clearance duty. And I think every factor which will affect the clearance of A beta from the brain will be in some way causal to it. We know from Bateman's work published in last December in Annals of Neurology that approximately 50% of amyloid beta turns up in the peripheral circulation, 25% going directly into the brain vessels and 25% going into the CSF, meaning that the other 50% have to be degraded locally. And locally means they have to be degraded by microglial cells through phagocytosis and intra or extracellular degradation. And all the factors which will bring that system out of balance, in my view, could be causal of Alzheimer's disease of the sporadic type.
I'm interested to know how might external factors that can interfere with the immunological processes in the brain, such as systemic inflammation or obesity, how do these affect the progression of Alzheimer's disease?
So just to give you a little overview of the evidence, there's the American Health Retirement Study, which has been published in JAMA 2010 by Jack Iwashima. What he showed is that people who experience severe sepsis have a higher likelihood turn into dementia during the aging progress. And we had a paper where we showed that sepsis survivors end up with hippocampal atrophy and neurocognitive deficits in this in a level which comes close to MCI. And experimental work from various labs shows similar data in mouse and rat models. But most importantly, Clive Holmes from Southampton had a paper in Neurology published in 2009 showing that infection is driving patients into Alzheimer's disease depending on or associated with TNF-alpha levels in the peripheral blood. So I think that this all is evidence that peripheral inflammatory stimulus somehow aggravates or fuels processes in the brain which accelerate or lead to Alzheimer's disease.
Do we have treatments available that could help to inhibit the inflammatory reaction in Alzheimer's?
I'm not sure if we have drugs on hand which could make a big difference as in the moment the patient is suffering from Alzheimer's dementia. I think the most important phase of interfering with inflammatory mechanisms may be much, much earlier, MCI or pre-MCI stages. And there we have at least epidemiological evidence that drugs which are thought of act as anti-inflammatories can provide benefit.
Hello, and welcome to the Lancet. Be taken to target immune. Hello, and welcome to the Lancet Neurology podcast. My name is. These immune mechanisms ultimately to allow us to delay or prevent the development of the disease.
Well, there is certainly some need to develop new and more complex Alzheimer's disease animal models. What I think of is bringing the life of our patients into experimental reality. You know, we have patients who have years of hypertension, of obesity, of reduced physical activity, maybe mild brain trauma, all things which drive the disease, which are exposed to various types of infections throughout their life, and then develop the disease. And we don't understand the interaction of these factors with brain function, and we also don't understand the interaction of these external factors with different gene patterns. For example, one of the number one risk genes, ApoE4, has not been strongly investigated with respect to all these external risk factors. And there might be some interactions. I think this is important. And the second thing is to identify biomarkers. If we want to target inflammation in the brains of future AD patients in the pre-phases of the disease, then we have to have appropriate biomarkers. And we also need to define the various periods. You may know that the disease starts in, for example, the entorhinal cortex and then spreads from there to other brain regions. So it means that we don't have one brain area which is in the same stage of disease as the other. So we have to define in which stages inflammation plays a role and in which not. And on the other hand, we have to have a preventive clinical trial. I think this is of utmost importance to prove that inflammation is indeed a driving factor, and those preventive trials will need joint action because those trials are expensive, they're laborious, and they need to be started years ahead before disease clinically appears.
Michael, I'd like to ask you one final question, if I may. Now, it seems that our views about the role of the immune system in neurological disorders have changed dramatically over the past few decades. How important are these immune mechanisms in other neurological conditions?
So first of all, you and me might still remember that we have been taught that the brain is an immune-privileged organ, which, of course, it is not. We just have to look a bit sharper and longitudinally, and we see that the brain is involved in immune processes, in innate and in adaptive immune processes throughout the entire life. So I think that view indeed has been changed a lot. But I think that there is increasing evidence from other neurodegenerative disorders like Parkinson's or Huntington's or amyotrophic lateral sclerosis that inflammatory mechanisms play an important role and contribute to disease progression, to symptoms and syndromes, and can offer potential targets in future. I think the strongest evidence exists certainly for Alzheimer's and Parkinson's, but I think there's a number of other degenerative disorders which are important to be studied into that direction. Another thing is that we have a lot of immunological and autoimmune disease, such as multiple sclerosis or others, which certainly have their whole own inflammatory component and immunological component, and there is a lot of interactions on that side on these type of diseases with the brain as well.
Michael Haneke, thank you for the fascinating insight into this review and taking the time to speak with me on the Lancet Neurology. Hello and welcome to the Lancet Neurology.